In this video we're going to look at finding the surface area and the volume of spheres and cones. The volume of a sphere is 4/3 pi r cubed and the surface area is 4 times pi r squared. For a cone, the volume is 1/3 times pi r squared times h, where h is the height of the cone. Whereas the curved surface area, and it's just the curved surface area, it's pi times r times l, where r is the radius and l is the slant. Okay, so in these questions, what we may have to do is consider the right angle triangle formed when you join the height, the radius, and the slant, because quite often we're only given two pieces of those information. And then we could use Pythagoras' theorem, because r squared plus h squared will equal l squared. If we're asked to work out the total surface area, then we would need to add on the area of the base, which is the circle, so that would be pi r squared. These formulae are provided in the formula sheet. And again, cones can be open or closed. An open cone would mean that the area would not have to be included. A closed one or a solid one, you would have to include the base area for total surface area. Now in chemistry, whenever you were working with filter paper, what you maybe did was have a circular piece of filter paper and cut out a sector like this, and then what happens is you could fold that around and it would make a cone. So a cone is really just a sector of a circle which has then been joined up to form a cone. So the arc length of a sector, so that's the curved part at the bottom, is equal to the circumference of the cone. The area of the sector, well, that's going to be the curved surface area of the cone. The radius of the sector is the slant length of the cone. And then we can use, as we said before, r squared plus h squared to equal l squared, where r is the radius of the circle, l is the slant, and h is the perpendicular height of the cone. Example 30, a sector with a sector angle of 288 and radius 10 is folded to make a cone. Find the radius of the base of the cone. So what we just looked at and what we said was the radius of the base of the cone. So the base of the cone, that was coming from the length of the sector. So the length of the sector was theta over 360 times 2 times pi times r. So that's going to be 288 over 360 times 2 times pi times 10. And that works out to be 50.265. So that's 50.265 then is now the circumference of the cone. So C is 2 times pi times r. The circumference then is 50.265, which is 2 times pi times r. And if we divide by 2 pi, we'll get that the radius is going to equal 8. And to do that, we divided both sides by 2 pi. So that's part A done. Part B, we need to work out the height of the cone. So what we've got is the radius of the sector, which we knew was 10. It's going to be the slant length of the cone. And we've just worked out the radius to be 8. So if we're trying to work out the height of the cone, we use Pythagoras' theorem, so a squared plus b squared equals c squared. A is 8 squared. B, we're trying to find is the height, h squared, and that's going to equal the hypotenuse squared, which is 10 squared. So that's 64 plus h squared equals 100. Take away 64 from both sides, we get h squared equals 36. So then h is going to be the square root of 36, which is 6. Now a cone is really just a special type of a pyramid. A pyramid, remember, is a three-dimensional object which goes to a point. So a cone does that. This triangular pyramid also does that. We could have a square-based pyramids, much like the pyramids of Giza. And for whatever pyramid we've got, the formula is going to be a third of the base area times by the perpendicular height. So for this pyramid, what we can say is a triangular base pyramid. So the volume is going to be a third of the base area. The base area is a right angled triangle, so that's a half times 5 times 6 times by the perpendicular height, which is 4. So that's a third times 15 times 4, which works out to be 20 cubic centimetres. Now, half a sphere is called a hemisphere. That shouldn't come to a surprise to us since we live in the northern hemisphere, which is the northern part of the Earth. So we've got the northern and the southern hemisphere. And a hemisphere, again, can be open and closed, depending on when we need to consider that whenever we're thinking about surface area. We may be asked to work out the capacity of an object. Now, capacity is just the same idea as volume. It's just a measure of how much an object can hold, but very often we're asked to give our answers in litres, and the conversion between litres and cubic centimetres is that 1,000 cubic centimetres is equal to 1 litre, or 1,000 millilitres. So 1 cubic centimetre then must equal 1 millilitre. So example 32, find the volume and surface area of part A, a sphere of radius 4. So what we have is the volume of a sphere is 4/3 times pi times r cubed, which is 4/3 times pi times 4 cubed, 4/3 times pi times 64, and putting that into your calculator, we get 268.08 cubic centimetres. The surface area is 4 pi r squared, which is 4 times pi times 4 squared, which is 4 times pi times 16, which is 201.06 squared centimetres. Part B, an open cone of radius 4 and height 3. So I'm going to sketch out my cone. The radius is 4 and the perpendicular height is 3. So the volume is a third times pi r squared times h, which is a third times pi times 4 squared times 3, which is a third times pi times 16 times 3, which is 50.27 cubic centimetres. Now to work out the surface area, and this time it's an open surface area, so that means there's no base. We need to do pi RL, where L is the slant. So to work that out, we're going to have to use Pythagoras' theorem. So for that, we've got 3 squared plus 4 squared must equal L squared. That's 25 equals L squared, so L equals 5. And that's because our right angle triangle, we've got A, B and C, so A squared plus B squared equals C squared. So now we can work out the area, the curved surface area, and it's going to be pi times 4 times 5, which is 20 times pi, which is 62.83 squared centimetres. Part C, a hemisphere of radius 10. So the volume is going to be 4/3 pi r cubed divided by 2, which is 4/3 times pi times 10 cubed divided by 2. So 4/3 times pi times 1,000 divided by 2, which is 2,094.4 cubic centimetres. The surface area, so for a hemisphere, we've got the base area to consider as well. So we're going to have the curved surface area, which is going to be 4 pi r squared divided by 2. And then we're going to add on the base, which is pi r squared. So that's 4 times pi times 10 squared divided by 2 plus pi times 10 squared. So that's 4 times pi times 100 divided by 2 plus pi times 100. This actually simplifies. So the bracket is 400 pi divided by 2 is 200 pi plus another 100 pi, which is 300 pi, and that is 942.48 squared centimetres. Of course, we don't need to work that out in terms of pi, but it's very easy to do so. Example 33, a solid cube has a length of 5 and a density of 8 grams per cubic centimetres. Find its mass. Now, contained within the units of density, what we've got is grams per cubic centimetres. That's grams divided by cubic centimetres, and that's what density is equal to. Now, what we've got then is density equals mass. So grams are to do with mass, and centimetres cubed is to do with volume. So from that we can determine a triangle, a mass density volume triangle. So density is mass over volume. So then from there we can work out, if we're looking to get the mass, it's going to be density times volume. So what we need to do then is work out the volume of this cube. So volume of a cube is L cubed. So that's going to be 5 cubed, which is 125 cubic centimetres. Mass then, we've looked to see where this triangle comes from, and we know that mass then is going to be density times volume, which is going to be 8 multiplied by 125, which is 1,000 grams. So whenever we've got units given in this way of grams per cubic centimetres, it really means grams divided by cubic centimetres, which is mass divided by volume. And we can apply the same for anything. So we know that speed, the units of speed, would be meters per second. So speed then is going to be meters divided by seconds, which is distance divided by time. Example 34, find the surface area of this compound shape. So this looks like a solid shape. So what we're going to have is a circular base. We're going to have the curved surface area of the cylinder, and we're going to have the curved surface area of the cone. Now the curved surface area of the cone is pi RL. The curved surface area of a cylinder is 2 pi RH, and the area of a circle is pi r squared. So those are the different parts. Now L is the slanty length, so what we're going to have to consider then in this is forming a right angled triangle from the top of the cone down to the height, to the radius, and then back up again. So we've got R, H and L. The radius is going to be half of the diameter. The diameter we can see is 4.8 meters, so the radius is going to be 2.4. The height is 3.2, so using R squared plus H squared equals L squared, we've got 2.4 squared plus 3.2 squared equals L squared. So 16 equals L squared, so L then must equal 4. So area of the cone, curved surface area of the cone, we've got pi times 2.4 times 4, which is 30.159 squared centimetres. For the cylinder, it's going to be 2 times pi times the radius, which is 2.4 again, and the height of it is 2.2, so that's 33.175. The circle is pi times 2.4 squared, which is 18.096. So the total found by adding the cone, the cylinder, and the circle works out as 81.43 squared centimetres to 2 decimal places. Example 35, find the surface area of a sphere with a volume of 50. So what we know about the volume of a sphere is it's 4/3 times pi times r cubed. We're told the volume is 50, so what we can do is we can work out the radius. So if we divide both sides by 4/3 pi, we'll get 9.549 is equal to r cubed. And then if we take the cube root of 9.549, we'll get r, and that works out to be 2.122 centimetres. So now we can work out the area, and the area is 4 pi r squared, which is 4 times pi times 2.122 squared, which works out as 56.56 squared centimetres to 2 decimal places. And finally, example 36. A cone of radius 8 has a total surface area of 450. So what we've got is a total surface area. So that's the base plus the slant. So the surface area is pi r squared plus pi rl. And the radius was 8. And the total surface area was 450. So we can put that information in, and we get 450 is equal to pi times 8 squared plus pi times 8 times L. So 450 equals 201.062 plus 25.133L. So if we move the 201 to the other side, we'll get 248.938 equals 25.133L. So if we divide through by 25.133, we'll get L to equal 9.90 centimetres. Now we're asked for the volume of this cone, and the volume, remember, is 1/3 times the base area, so that's pi r squared times the perpendicular height. Now we've just worked out the slanty height, and we know the radius, so then to work out the height we'll have to use Pythagoras' theorem. So that's r squared plus h squared equals L squared. So that's 8 squared plus h squared equals 9.90 squared. H squared then is going to be 9.90 squared minus 8 squared, which is 34.11. So h then is the square root of 34.11, which is 5.84. So now we can work out the volume. So it's 1/3 times pi times 8 squared times 5.84, which is 391.4 cubic centimetres.